In the previous chapter, we have discussed different types of alternative energy sources, conventional and non-conventional energy sources, and we have also discussed the advantages and the disadvantages of those conventional and non-conventional energy sources. And we have also discussed what is the need for us to go for an alternative energy sources. So while discussing about all the energy sources, we have discussed different types of non-conventional like wind energy, tidal energy, wave energy, ocean thermal energy conversion systems, geothermal energy systems. Not only non-conventional, even in the conventional also, we have discussed the fossil fuels, coal, tar, so tar oil or oil shells. We have discussed different types of energy sources. Every energy has got its own advantage and disadvantages. Say, for example, if you take any wind energy is free of cost, no pollution, nothing, but it makes more noise. That is the first thing. And my dear friends, I want to highlight one point over here. When we talk about the non-conventional energy sources, we always talk about the advantages more. Basically, even they have got a disadvantages. A few are like this. Say, if you want to install any windmill, so obviously it takes more costlier. Initial investment is more. And one more thing is, all the 365 days, we cannot expect the wind to blow with the same velocity, isn't it? So if you take solar energy, all the part of the earth will not be exposed to the same thing. Maybe from morning 6 to evening 6, the temperature or the radiation varies time to time. So the radiations or the peak temperature at in the afternoon is entirely different when it is compared to the morning 6 o'clock or even in the dusk, that is in the evening 6 o'clock. So the temperature variations does take place. That is one of the major disadvantages of drawbacks of the solar energy. And after 6 o'clock in the evening till morning 6 o'clock, we will not have any solar radiations. And in particularly, radiations will not be uniform throughout the Earth's surface. Is it clear? Now, even I was talking about biomass or a biofuel. Once if you cut the wood, if you cut the tree and use it for some other purposes. So once again, if you want to grow the trees, it may take around 20 years. 20 years, do we have the time to wait and utilize those energy sources? It is not possible. So when you come to the conventional energy sources, and one more point to be highlighted, in non-conventional energy sources, the power generation is not very fast. That means instant energy or instant power that we cannot get it. And one more point is, while using the non-conventional energy sources, the amount of power that we are getting, it is not huge when it is compared to the conventional energy sources. The conventional energy sources has got a processing is required, whereas the non-conventional energy sources, we can utilize the energy sources as available in nature directly, whereas the conventional energy sources, for example petroleum products, we cannot use it directly, we need a processing. But the major advantage of fossil fuels or the conventional energy sources are that we get instant energy and more power compared to the conventional non-conventional energy sources. So in that context, among all, if you mix the conventional and non-conventional energy sources, the permanent energy source or the cleanest energy source is the energy that we are getting it from the sun. How we are getting the energy from the sun? It is by the solar radiations. What do you mean by, basically what do you mean by radiations? We always say radiations. Say for example, even the electronic or computer science people, they are more use this radiation. What do you basically means a radiation? Radiation is nothing but a radiant energy. Even if you are using a mobile, there will be some radiation effects. That means energy which are transmitting, which we cannot see with our eyes. Is it clear? See, there is some heat or incandescent is there. Idlu, Kenda, or incandescent thing. If you touch it, you feel the heat. Whereas the radiant energy, only you can experience it and you cannot see the radiant energy. So, if the solar radiation is a radiant energy, which has been emitted by the sun. Particularly because, as I've already told you, above certain atmosphere, beyond this Earth atmosphere, we don't have anything. The space is empty. Neither we have an air nor we have some any material medium. In such things, what happens? The radiant energy reaches to the Earth's surface by the electromagnetic energy or electromagnetic waves, and we also call it as a packets of energy, which we call it as photons. Is it clear? The solar radiations or the radiant energy which are reaching to the Earth atmosphere by electromagnetic waves in the form of electromagnetic waves. Is it clear? About half of the radiation is in the visible short wave part of the electromagnetic spectrum. Short waves, the half of the solar radiations. When we are getting a radiations, we will categorize the solar radiations into different categories. That I'll come to that later in the next chapter. So what happens? These radiations, half among all the solar radiations, half of the radiations comes under visible short wave part of the electromagnetic spectrum. That is the reason why whenever the solar radiations falls over here, we could able to see around us. Is it clear? Say, for example, if you can see certain things over there, if you see a surface is green, it is appearing green means it is reflecting only green color. Remaining thing it is absorbing. If you are seeing something, some object with a white color, that means it is reflecting all the colors. Something if you are seeing a black color, that means it is absorbing all the radiations and reflecting nothing. Then a body will appear black. If you see, if you are seeing, if you can see some leaf or a tree is appearing like a yellow color, that means it is absorbing all the radiations and reflecting only yellow color back. So that is the reason why it appears to be in yellow color. Is that clear? That is all because of this radiations effect. The other half is mostly in a near infrared part with some in the ultraviolet part of the spectrum. So obviously, whether solar radiations which are reaching to the Earth's surface, not only Earth's surface, the solar radiations which are coming out of the sun. Sun is a star. Is it clear? Why we call it as a star means it because it has got its own light and heat. It has got light of its own, so we call it as a sun, as a star. So the radiations which are coming out of this sun has got two different parts. Half of the solar radiations falls within the visible short wave, whereas the half falls with the rest, and this rest will have infrared radiations and ultraviolet radiation in the spectrum. By the way, what do you mean by spectrum? Spectrum is nothing but when you allow the light to pass through it, certain object or a radiations which are coming out, these radiations can also be categorized into different types based on the wavelength or the frequency. That is what we call it as a spectrum. Is it clear? So the geometry of the sun earth relationships is shown in this figure. The distance between the sun and earth varies by 1.7% due to the elliptical orbit of the earth around the sun. Uh, Certain occasions, actually, I just shall explain you, and later I will tell you. Sometimes, have you seen a moon will be in orange color? Sometimes you will see the moon will be in white color. So orange and white color. In most of the things, most of the occasions during the time of January, we always seen a moon in an orange color. Have you ever tried to know what is the reason behind of moon appearing in orange color? It is because, as we know, Earth moon is rotating along the axis around the Earth. Is it completely circular? No. Sometimes it will come very close. Sometimes it will go very far. So whenever this distance varies, the appearance of the moon also varies. I will talk to this point later when I concentrate on tidal and wave energy also. Is it clear, my dear friend? Likewise, when this is the sun and this is the earth, earth is revolving around the sun and it is not circular, it is elliptical. It is elliptical like this. So, what do you mean by elliptical means you will have a minor axis and major axis, right? What do you mean by major axis? The distance will be more. What do you mean by a minor axis? The distance is very less. So it is going all around. Because of this elliptical movement rotating of this Earth around the Sun varies 1.7% with that distance. Is that clear? I will come back to that moon. Why does it looks orange? It is only because the distance variations. When it is very close, we look it like a white. When it is too far away from the Earth, then it appears to be orange. So only it is called as popularly wolf moon. It is in the month of January. We often see that in orange color. It is because of this reason. Okay, now let me talk the mean Earth distance from the Sun. It is 1.495 into 10 to the power of 11 meters. It is, or else you can take it as 10 to the power of 8 kilometers. Is it clear? The Sun subtends an angle of 32 minutes with the Earth. What do you mean by subtending? Subtending, that is what you can see it here in the sketch. Subtension means the orientation. Here you can see this subtension at that particular point, at any particular point of the Earth is given by 32 minutes. It is the Sun is subtending by 32 minutes with the Earth. Okay, now the diameter of the Sun is 1.39 into 10 to the power of 9 meters. The diameters, whereas the Earth diameter is 127 or 1.27 into 10 to the power of 5 meters. Is that clear? So now the distance between the Sun and Earth, it is given by 1.495 into 10 to the power of 11 meters. Don't worry about this GCS. G suffix SC, it is nothing but a solar constant. I will come to that later on. It is 1.3 kilowatts per meter square. I will tell you this terminologies. What do you mean by solar constant? All those things later on. Now, as of now, the diameter of the Sun and the diameter of the Earth and the distance between the Earth and the Sun. This sketch is also important for you people to draw it in the examination. The diameter of the Sun and the diameter of the Earth and the distance between the Earth and the Sun. Now, my dear friends, one more important point is, if the Earth diameter is 1.39 into 10 to the power of 9 meters, so even then we cannot reach that surface. It is an approximation method. It is only because though the diameter is so and so, the radiation's effect will be more because the nuclear fusion reaction will be taking place on the Sun surface. Though the core is very less, its radiation effect will be of very higher. One example I'll tell you. If you take a wood, you burn it, the wood is only this much. The flames will be of certain height. Are you getting my point? The wood is only this surface. The wood surface is only this much. Though the wood surface is this much, if you subject it to burning, the fumes will be up to this height, isn't it? Though the surface is this much, it will extend its fumes up to certain height. The same way, the Sun's surface is only so much, but still it will have an extended burning fumes about this surface. Is it clear? So the diameter of the Sun is so and so, and the Earth is so and so. Is it clear? Now, beam radiation and diffuse radiation and global radiation. Actually, it's a very interesting topic. If I'm not wrong, I have given some figures over here. Now, if you check this figure, if you see this figure, there is a Sun, and this is atmospheric layer. Atmospheric layer. It is only atmospheric layer. That means above the Earth, there is some atmosphere which is available. That is what I have highlighted over here with the atmospheric layer in the blue color. Now, what is happening is the Sun, from the Sun, the solar radiations are reaching to the Earth atmosphere. Once it reaches the Earth atmosphere, what happens? The Earth atmosphere has got lot of dust particles, dirt particles are there, water particles are there, air is there, ozone is there, and clouds will be there, moisture content will be there. So many things are there in the Earth atmosphere. The solar radiations which are coming and entering into the Earth atmosphere, please, my dear friends, concentrate here. The solar radiations which are entering into the Earth atmosphere, the radiations, a part of the radiations will be deflected and reflected. They will be deflected and also reflected because of the water particles, because of the ozone layer, or because of the dust particles which are present in the Earth atmosphere. I'm talking about Earth atmosphere above the Earth surface, Earth level. That is our level. So what happens once these solar radiations enter into the Earth atmosphere? They will be deflected and will also be reflected. Those radiations which are touching the Earth's surface, that is what we call it as the diffuse radiations. Diffuse radiations, this is also called as a reflected radiations. The solar radiations which are reaching to the Earth atmosphere, before it reaches the Earth atmosphere, they will be reflected and deflected due to the presence of water particles, or maybe the dust particles, or maybe any air particles which are present in the Earth atmosphere. So those radiations, which we call it as the diffuse radiations, or we call it as a reflected or a secondary radiations. Now, in case of the radiations which will not get deflected by anything. Now, sir, how it is possible? How it is possible? It is only because I'll give you one small example. How this rainbow will form? Whenever the solar radiations are there, if the rain comes, solar radiations are coming to the Earth's atmosphere. Meanwhile, if it rains, if one solar radiation, one single radiation, if it penetrates through the one water particle, then the spectrum will be formed. That is Vib Gaya. That is what we call it as a rainbow. That means all the radiations may not have a chances of penetrating through the all particles. Few will penetrate and few will not. Is it clear? Likewise, there are few radiations, the radiations which are reaching to the Earth atmosphere without any deviations or reflection. Directly it will fall onto the Earth atmosphere. That is what we call it as a direct radiation, or we call it as a beam radiations. Is it clear? So similarly, global radiation is a total shortwave radiation from the sky falling onto horizontal surface on the ground. It includes solar radiation and the diffuse radiation. Direct radiation is nothing but a beam radiation, and diffuse radiation is nothing but the reflected radiations. So once again, I would like to give the definitions over here. Beam or direct radiation that that does not get absorbed or scattered but reaches the ground from the sun, which produces shadow when interrupted by the opaque object. So that is what we call it as a beam radiation. Diffuse radiation, solar radiations received after it's been changed because it has been deflected, it has been scattered. Okay, changed by the reflection and scattering in the atmosphere. I would like to extend this definition. Solar radiation received after been changed by reflection and scattering in the atmosphere due to the presence of water particles, dust particles, and any air particles which are present in the Earth atmosphere. That causes diffuse radiation. Then what do you mean by global radiation? Global radiation is nothing but the total radiations which are reaching onto the Earth atmosphere. That is what we call it as a global radiation. It is sum of beam radiation and diffuse radiations. Now, if you come to this, if you can see this sketch figure, wherein which reflection is taking place, scattered and plus absorbed aerosol, and then it will reach. This is a diffuse radiation where you can see it has been reflected. Whereas the direct or a beam radiation, which is not getting deflected or scattered directly, which is Earth atmosphere, that is what we call it as the direct or a beam radiation. Did you understand? Fine then. Now, what do you mean by extraterrestrial? No, here the from the figure itself you can make it out. Solar radiation incident outside the Earth atmosphere is called as an extraterrestrial. That means, as I repeated, every Earth Earth has got its own atmosphere up to certain height. After that, we don't have any Earth atmosphere. So the solar radiations that are falling above the Earth atmosphere is called as an extraterrestrial. On average, the extraterrestrial radiations now the solar
ಸರ್
radiations incident outside the Earth's atmosphere.
ಸರ್ ನೀವೇನು ನಿಮ್ಮ ವಾಯ್ಸ್ ಕೇಳ್ತಾ ಇಲ್ಲ ಸರ್. ಹಲೋ ಸರ್.
Okay. Now, on an average, the extraterrestrial irradiance is 1361 or 1.36 watts per meter square. This value varies by 3 plus or minus 3% as the Earth orbits the Sun.